All right, chapter 26. My difficult book made simple for Annie and George, version 3. It began, What you need to know about black holes. Section 1, What is a black hole? Section 2, How a black hole is made. Section 3, How can you see a black hole? Section 4, Falling into a black hole. Section 5, Getting out of a black hole. Section 1, What is a black hole? A black hole is a region where gravity is so strong that any light that tries to escape gets dragged back. Because nothing can travel faster than light, everything else will get dragged back too. So you can fall into a black hole and never get out again. A black hole has always been thought of as the ultimate prison from which there's no escape. Falling into a black hole is like falling over Niagara Falls. There's no way of getting back the same way you came. The edge of a black hole is called the horizon. It's like the edge of a waterfall. If you're at the edge, you can get away if you paddle fast enough. But once you pass the edge, you're doomed. As more and more things fall into a black hole, it gets bigger and bigger, and the horizon moves farther out. It's like feeding a pig. The more you feed it, the larger it gets. Section 2. How a black hole is made. To make a black hole, you need to squish a very large amount of matter into a small space. Then, the drag of gravity, or the pull of gravity, will be so strong that the light will be dragged back, unable to escape. One way black holes are formed is when a star burns up their fuel, explodes like giant hydrogen bombs, and it's called a supernova. The explosion will drive off the outer layers of the star in a great expanding shell of gas, and it will push the central regions inward. If the star is more than a few times the size of our sun, a black hole will form. Much larger black holes are formed inside clusters inside the center of galaxies. These regions will contain black holes and neutron stars as well as ordinary stars. Collisions between black holes and other objects will produce a growing black hole that swallows anything that comes too close to it. Our own galaxy, the Milky Way, has at its center a black hole several million times the size of our sun. Section 3. How can you see a black hole? The answer is you can't, because no light can get out of a black hole. It's like looking for a black cat in a black cellar, but you can detect a black hole by the way its gravity pulls on other things. We see stars that are orbiting around something, but that we don't know if it can be a black hole. We also see disks of gas and dust rotating around a central object that we can't see, but that we know it can only be a black hole. Section 4. Falling into a black hole. You can fall into a black hole just as you can fall into the sun. If you fall in feet first, your feet will be closest to the black hole, and your head will be pulled harder by the gravity of the black hole. So you will be stretched out lengthwise and squished in sideways. This stretching and squeezing is weaker than the bigger the black hole is. If you fall into a black hole made by a star only a few times the size of our sun, you will be torn apart and made into spaghetti before you even reach the black hole. But if you fall into a much bigger black hole, you will pass the horizon, the edge of the black hole, and the point of no return, without noticing anything in particular. However, someone watching you fall from a distance will never see you cross the horizon because gravity warps time and space near the black hole. To them, you will appear to slow down as you get closer to the horizon and get dimmer and dimmer. You get dimmer because the light you send out takes longer and longer to get away from the black hole. If you cross the horizon at 11 o'clock, according to your watch, someone looking at you would see the watch slow down and never quite reach 11 o'clock. Section 5. Getting out of a black hole. People used to think nothing could ever get out of a black hole. After all, that's why they called black holes. Anything that fell in would be lost and gone forever. Black holes would last until the end of time. There were eternal prisons from which there was no hope of escape. But then it was discovered that in the picture wasn't quite right. Tiny fluctuations in space and time meant that black holes could be the perfect traps. They couldn't. They were once thought instead they would slowly leak particles in the form of Hawking radiation. The rate of leaking is slower the bigger the black hole is. The Hawking radiation would cause black holes to gradually evaporate. The rate of evaporation would be very slow at first, but it will speed up as the black hole gets smaller. Eventually, after billions of years, the black hole will be gone. So black holes aren't prisons after all. But what about their prisoners, the things that are made in the black hole that fell in later? They will be recycled into energy and particles. But if you examine what comes out of the black hole very carefully, you can reconstruct what was inside. So the memory of what falls in the black hole is not lost forever, just for a long time. You can get out of a black hole.